Welcome back to Algebra 2 Homework Help. Today we're going to be graphing quadratics using X-intercepts to guide our graphing process. So today we're going to do problems 1, 3, and 5 from the homework. Let's just jump right in with some quick notes. So if I'm finding X-intercepts, pardon the funky graph. Okay, let's say this is my parabola. Let's call it f of x. In this case, our x-intercepts, that means anywhere you're hitting the x-axis along here, are going to be located right here and right here. And what you'll notice about any point that's on the x-axis, if we were to give it some values, that could represent the coordinate, this could be like 3, 0. And this guy over here could be like -4, 0. But what all of these points on the x-axis are going to have in common is that the y value equals 0. Now recall, the y value is basically the height of the graph. So if I say I have a point over here at +1, -4, well, the height of my graph, the height equals -4. The y value is -4. But that isn't an x-intercept then. Anytime I'm intercepting the x-axis, my height has to be 0 because I'm not going to be above the axis, I'm not going to be below the axis, I'm going to be right on it. So if I have a function and I need to find the x-intercept, let's see, here's my function. In order to find what those points are where I'm actually hitting the x-axis, I'm going to go ahead and set y equal to 0. Another way of saying y is f of x. So I'm going to set this guy equal to 0. And this is what it really looks like. If I'm setting f of x equal to 0, well, that f of x is really this whole function here. So I am going to solve by saying ax squared plus bx plus c equals 0. And then what I'll be doing is solving a quadratic equation. Look back to your notes from 2.7. And that's where we were coming up with many methods to solve a quadratic equation. Some of those methods were GCF, we used magic X, we used difference of squares. So that's 3 methods right there. And then a fourth and final method as a last resort was called the quadratic formula. And so this is when we get to apply these methods again. Okay, we're going to be solving this equation, ax squared plus bx plus c equal to 0. So please put this in your notes. Anytime we're finding the x-intercepts, we set the function equal to 0, and then we solve our quadratic equation for x. Let's do a problem. Okay, number 1 says f of x equals x squared plus 4x minus 5. So let's start by finding our x-intercepts. Remember, to find our x-intercepts, we're going to set the whole function, that's this guy, equal to 0. And then solve. Well, in this case, I've got 3 terms. So the method that I'm going to start trying with is magic X. I need 2 numbers that multiply to -5, add up to +4. So let's think a little bit. The only 2 numbers that multiply to 5 are 1 and 5. And if I want it to add up to 4, then the 1 needs to have the negative sign. So I'm going to factor it like this. X minus 1, x plus 5 equals 0. And then by setting each factor equal to 0, I'll show my work here on the side. I'll solve for x. Oh gosh. So I'll solve for x and get x equals 1. Okay, by doing the same thing with my second factor, I get x equals -5. And these are going to be my x-intercepts. So notice that we just have a number, 1 and -5. But these really represent points. So look over here. To get our x-intercepts, we need to report them as points. Well, we're going to stick our x values that we just found in the x spots. So that gets a 1. This guy is negative 5. And remember, since we're on the x-axis, our y value has to be 0. So let's plot these over here. I have an x-intercept at 1, 0, and another at negative 5, 0. Okay. Cool. Next step, we're going to find our vertex. Now, since this is given to us in standard form, one thing we might do to find our vertex is complete the square. But to be completely honest, completing the square is something I'm only going to do if I'm asked to, if I'm really forced to. So instead of completing the square and getting this into vertex form, I am going to use a little clever trick here. Let's look back to our x-intercepts. We had 1 at negative 5 and 1 at positive 1. Well, remember, parabolas are always symmetrical, so that means that my vertex is going to be exactly halfway between negative 5 and positive 1. It looks like our vertex is going to be somewhere along this line. Okay, it might be up here and facing down, or our vertex might be down here somewhere facing up. We don't know. But what I do know is that my vertex has an x value of negative 2. And we can confirm this by taking the average or finding the halfway point between our x-intercepts. So here's how we do it. To find the vertex from the x-intercepts, we're going to add our x-intercepts together. So we got negative 5 and 1. And then we're going to divide by 2. And what we're really doing here is we are finding the average. EVG, average, or the midway point. Okay, the halfway point. So negative 5 plus 1 is a negative 4. And then taking half of that, we get negative 2. So we just confirmed what we already knew, which is that negative 2 is the number halfway between negative 5 and positive 1. So negative 2 is going to be the x-coordinate of my vertex. To find the y-coordinate, all I need to do is plug in negative 2 for x and see what I get as my y value. So let's do that down here. F of negative 2 equals negative 2 squared plus 4 times negative 2 minus 5. So that's 4 minus 8 minus 5, which is negative 4 minus 5, which is negative 9. So when x is negative 2, y is negative 9. That's our vertex. So I'm going to go halfway, and our vertex was down here. Negative 2, negative 9. Very cool. So we've got our vertex. We can start connecting these as a smooth curve. And there we go. Okay, so we need our y-intercept, and I kind of overlooked that right there. I connected these as a curve without really finding the y-intercept first. So let's go ahead and find it now and then adjust our curve if necessary. So to find the y-intercept, we're always going to set x equal to 0. So I know x is 0 already, and now I just have to plug it in. So f of 0, so this was to find the vertex. Now we're going to find the y-intercept. It's going to be 0 squared plus 4 times 0 minus 5. So since my first term is 0, that goes away. My second term multiplies to 0, that goes away. And I get f of 0 just equals negative 5. So when x is 0, my y is negative 5. Let's plot that here. 1, 2, 3, 4, 5. So my graph was just slightly off. I'm going to go ahead and redraw it, make it more precise. It's got to go through these points. So close. One more time. Whoosh. Nice. There's my curve. Okay, now we've got to talk about end behavior. So let's focus on our end behavior. So when we talk about end behavior, I want you to completely ignore the middle part of the graph. Only focus on the arrows. Those are the ends. We want to see how our graph behaves towards the ends. So on the left side, as x approaches negative infinity, that's to the left, our graph goes up forever. So our y is going to approach positive infinity. So as x approaches negative infinity, oh, that's this guy right here, our y approaches positive infinity. And on the right side, as x approaches positive infinity, so we'll focus on the right arrow, well, my graph is also going to positive infinity on the right side. So, positive infinity here. Okay, now, where is the graph negative? Negative means below the x-axis. So I am below, ouch, I'm below the x-axis in all of this area. Now we need to report this scanning the graph from left to right. So I begin my journey below the axis from -5 all the way until +1. The rest of the time, I'm above the axis, so I want to ignore those pieces. I just want to report from -5 to +1, my graph is below the axis, so in this area here. Cool. Now, last but not least, we've got to report our domain. So our domain, recall, for all quadratic graphs is always going to be -infinity to +infinity. Our arrows are going to the left and to the right forever in both directions. And then our range. So range, we're scanning from bottom to top. Well, from the bottom, our graph does not exist until this point right here. A y value of -9. And then from there, it exists and it continues existing all the way forever upwards. So it goes until +infinity. Just like that. And we finished problem 1. Let's try problem 3. This one should go much faster. So we have a new function. -x² minus 2x plus 1, we want to find our x-intercepts. So as before, we're going to set our function equal to 0. Let's do that down here. Equal to 0. So the first thing I'm going to do is I'm going to factor out a negative. I'm going to pull out a -1 from all three terms, which really just means I've got to flip all my signs. Because if I were to factor this back or distribute it back in, I get -x² minus 2x plus 1. So that's why we're flipping the signs anytime we factor out a negative. Now I'm just going to divide both sides by -1. And you'll notice that this disappears. And I have x² plus 2x minus 1 equals 0. Because 0 divided by -1 is just 0. Okay, now I've got something I can work with. I'm going to try magic x since there are 3 terms. I need 2 numbers that multiply to -1 and add up to 2. Well, if you think about it, the only 2 numbers that will ever multiply to 1 are 1 and 1. But for them to add up to 2, they've both got to be positive, but that doesn't really multiply to a negative number. And after much deliberation, I decide this cannot factor. So magic x won't work. Our last resort, when this happens, is we've got to use the quadratic formula. So I'm going to start by identifying my a, which is 1, my b, which is 2, and my c, which is -1. And now I get to plug them into the quadratic formula. So we're going to do this very carefully. X equals negative, my b is 2. Plus or minus, always put your b squared in parentheses, so your b is in the parentheses, and then you're squared outside, minus 4 times a times c. all over 2 times a. Let's simplify. That's negative 2 plus or minus. 2 times 2 is 4. Now this piece, negative 4 times positive 1 is negative 4. And then times a negative 1, well, these two negatives multiply to give me a positive 4. All over 2. Okay, let's simplify further. That's x equals negative 2 plus or minus square root of 8 over 2. I'm going to continue my work over here. Let's simplify the square root of 8. So you can use a factor tree to figure out how that simplifies. I do it like this with my students. It goes in 4 times. 2 goes into 4 2 times. I'm going to pull out the double. So square root of 8 can really be rewritten as 2 root 2. So I'm going to rewrite it like that right now. Now, once you get here, you will be tempted to cross stuff out, but you need to hold back. That's not mathematically okay. The only way that we can do this is to split the fraction into 2 pieces. So I'm going to rewrite this as x equals negative 2 over 2 plus or minus 2 root 2 over 2. And that would be the proper way to deal with this next. Now that I have it in 2 different pieces, I can simplify. This negative 2 over 2 becomes a negative 1 plus or minus, and these guys cancel out to just leave me with 1 over 1, which is square root 2. Now I'm going to use a calculator to see what square root 2 actually is. So you can't see me right now, but I'm actually using a calculator. The square root of 2 is 1.414. So really what I've got is negative 1 plus or minus 1.4 approximately. Well, negative 1 plus 1.4 is 0.4 approximately. And my other x-intercept, negative 1 minus 1.4, is approximately negative 2.4. It's not the most beautiful solution, but this is really where our graph is hitting the x-axis. So I'm going to go ahead and write 0.4 as my first x-intercept. Remember, our y is equal to 0, and then negative 2.4 as my second, comma 0. Okay, let's go ahead and graph those. 0.4 is approximately here between 0 and 1, and then negative 2.4, well, this is negative 1, that's negative 2. Negative 2.4 is right around here. So let's consider what's halfway between these two values. If I look back down at our problem, we were basically taking the number negative 1 and we were either adding root 2 to it or we were subtracting root 2 from it. So that makes negative 1 my halfway point. I can verify that by looking at my graph. They're both 1.4 away. So my vertex is going to lie somewhere along this line here, this x equals negative 1 line. So I'm going to go ahead and write in negative 1 as my x value of my vertex. Now to find the y value, we simply plug in negative 1 everywhere we see an x. So let's do that now. To find our vertex, let's see, we already know negative 1 is the x value. And so our y value is going to be, let's plug in negative 1 very carefully. Use parentheses everywhere you see an x. So I've got negative 1 squared minus 2 times negative 1 plus 1. Okay, well, negative 1 squared is positive 1, but then the negative out in front makes this negative times 1. Now, negative 2 times negative 1 gives me plus 2, and I'm just going to add that 1 at the end. Okay, negative 1 plus 2 is 1, plus 1 is 2. My vertex is negative 1, comma 2. That's right there. Finally, I need a y-intercept. So as always, we set our x equal to 0. So whenever we're finding our y-intercept, set the x equal to 0. Whenever you're finding your x-intercept, we set the y, or the function, equal to 0. It's the opposite of what it sounds like. So let's set x equals 0 and solve. So I want to find my y-intercept now. So we're doing g of 0 equals, now we're just going to plug in 0 carefully, negative 0 squared minus 2 times 0, and then plus 1. Okay, well, 0 squared is 0. This whole thing cancels. And then this guy turns into 0 also. And I'm left with g of 0 equals 0 plus 0 plus 1. And so my y-intercept is going to be, remember, this is our y value, so it needs to go in the y spot. And our x, we had set it equal to 0. My y-intercept is 0, 1. And now we get to connect it as a smooth curve. Looks like this. Very nice. Okay, let's focus on our end behavior. So that means we're looking at the arrows. So notice that both to the left and to the right side, our y values are approaching negative infinity. They're going down forever. So negative infinity and negative infinity. Where the function is decreasing, well, we'll start by tracing our graph from its leftmost point. Right here, my graph is increasing. It doesn't start decreasing till right here. The x value of negative 1, that's right here, and it's decreasing to the right. So from the x value of negative 1, and then forever onwards, from there till infinity, my function is indeed going down. Our domain is negative infinity to positive infinity, as always for these quadratics. And then our range, we need to scan the graph from bottom to top. So does our graph exist down here at negative infinity? Well, look at the arrows. They are going downwards. That means, yeah, it takes on all those negative y values. So our graph exists, we can say, from negative infinity until where? Well, it exists for these y values. It exists for these y values. Ooh, right until there. This is where it stops. So at the y value of positive 2. That's our range from negative infinity till positive 2. My graph exists for all these y values. And we're done. We've got one last problem to do. So this is a problem where we are given a graph and we're asked to match up the functions. Now notice we have functions in all different formats. So let's focus first over here on our vertex form. Well, the vertex of this graph is positive 1, let me zoom in, is positive 1, 4. So let's see if this function gives us that. Well, from this one, our vertex is flip the inside, that's negative 1, keep the outside, positive 4. And that does not match with ours, so we need a positive one. So this guy is out. Notice what would have made this correct is if the inside guy here, if this sign had been negative, then that would have given us what we wanted, which was positive 4. But alas, the sign was off, so this is out. Let's take a look down here. From this vertex form, I get the vertex to be positive 1, we're flipping the inside, positive 4, which does indeed match our vertex. So that guy looks good to me. And also notice that the negative out in front says we're facing down. And our graph is facing down. So I would say, yes, we've got the right vertex and we're opening up in the right direction. So we're good to go. So vertex form would be like the easiest thing to identify first of all. Check if it matches. From there, so yes, okay, let's put a no in the no column. Now from there, since we have decided that this does represent our graph, to get our standard form, that's these guys. instead of doing completing the square and all that fun stuff, I'm simply going to expand the vertex form that I've already said is correct. So in order to do that, we have to square x minus 1. That means, hey, take x minus 1 and multiply it by itself. Okay, we're going to FOIL this out carefully. That negative out in front, we're going to leave it. We're not going to touch it just yet. But we get x squared minus 1x plus 1. And the negative is going to be distributed in next, but first we have to add the 4 at the end. Okay, following the order of operations, we will deal with inside the parentheses first. So that means it's time to combine like terms. Again, this negative on the outside, it stays there, but we're holding off on it just now. So x squared minus 1x gives me minus 2x, and everything else stays the same. Okay, now that we've dealt with our parentheses and there is no exponent to take care of, now we can deal with multiplication. There is a negative 1 to distribute in, so all my signs flip. And finally, we can do our addition and subtraction. I get negative x squared plus 2x plus 3, and that would be my standard form. So let's look back and see which of our standard forms matches negative x squared plus 2x plus 3. Negative x squared plus 2x plus 3. That matches, so this is good to go. And this one down here, it does not match. So we know that's off. But there's another reason why we could immediately say that this one, why we could have canceled it out right away. And that's because notice there is no, my leading term is positive. That means that this graph must have been facing upwards. But our graph is facing down. So this one, we could have immediately ruled it out, actually. Okay, finally, let's look at this intercepts form. So according to this guy, our x-intercepts are going to be, if we had set it equal to 0, our x-intercepts are at x equals, we'll flip this guy, x equals negative 1, and at x equals positive 3. Let's see if that matches what we have. Negative 1 and positive 3. So it looks good. Also, there's a negative outside, meaning we're facing down. Our graph is facing down. So that function's good to go. And using that process of elimination, we have identified, if I were to number these, we've identified that number 2, number 3, and number 5 are the correct functions for this graph. Hope that was helpful. I'll see you next time.